so it has L diversity. And because it's a sample, it's probably close to the original, the full data set of all people in New Jersey, which is large enough. Maybe, I think maybe he's from Jersey. No, I'm not sure where he's from. But anyway, you can still kind of, then you could go and say, well, what's the population of New Jersey? Or what's the average height of a man in New Jersey? And maybe it's 5'6". And then, you look this way. So that's kind of how you think about it in terms of these problems. But if you give a lot of noise out in the process, maybe you can do a little bit better job of hiding. It's kind of the idea behind this idea of differential privacy. And so this is a fairly new kind of class of techniques for doing this, and it's still a very active research area. I forget the date, but the ideas are no more than 10 years old of trying to really formalize how you can really hide certain information based on the noise you had and understanding this sort of relationship. So I have one more kind of example, but I don't think I have time to go through this. So okay.
So is the noise, I wasn't clear, is the noise released to the public as well?
The noise model is. So you tell the public, I'm releasing it with this sort of Laplacian noise. And so you have some parameters. So this is some random variable coming from a Laplacian distribution with a certain standard deviation. And this amount standard deviation controls how accurate your queries can be. So you'd like your queries to be more accurate, but you'd also like to not give away too much information. And so this kind of controls the trade-off. And based on these sorts of preserving qualities, Laplacian noise is the right way to do it. You could think, why not use Gaussian noise instead? These things don't cancel as mean. Basically why. You can, if you have exponentials, you can essentially add these, or subtract this one from this one. Subtracting minus 3 epsilon is adding 3 epsilon. So that's how you get the plus epsilon. Yeah. So there's been various work in how can you compute or release certain kind of higher level descriptors of data while still being differentially coupled. So let's say you wanted to compute the PCA of your data without being able to releasing too much information. If you release the PCA, well, how is that different from one of these other models, these can-anonymized models? Maybe you can use other information to reconstruct something. So you want to release PCA, but with some amount of noise added. So you have some prevention that under some certain probabilistic models you can't recover information about. So there's been a lot of kind of work in this area. And some people believe that this will never be really practical. Other people think that you can do it. And so it's still an open question, but it's controversial in some ways. All right.